Hello guys, today I will be explaining you the stratified train test split. Okay, uh, in the last day I have told you what is train test split. That is, you have a data set and you have to split that into train and test data, and that will also divide into x train, x train, y train, and x test, y test. Okay, so you can watch that in the previous video. I will be giving you the link of the video in the description. Okay, so today I will be teaching you the stratified test. What is stratified? Means suppose you have the data set. This is the data set, and this is the y column. These are the x columns, and in the y column this is a classification problem, and in the y column there are two suppose in y column there are two categories. One is 1 and one is 0, suppose. Okay, and in the whole data set, 1 is like 90% and 0 is 10%. Means in y column, 1 is suppose the total number of rows are 100, then number of 1 are 90 and number of 0 are 10. Okay, so this is the distribution. Suppose the distribution is like this. This is the distribution 1 and 0. This is the bar plot. Okay, so if you do normal train test split in the train data and in the test data, this can happen like in the train data. In y train, the percentage of 1 is suppose 92%, and percentage of 0 is 8%. Okay, instead of 90 and 10, 92 and 8 are there. Okay, and in the test also you can get like percentage of 1, percentage of 0, like 9 like 89% and 11%. This is not consistent. These values are different. This is not matching with this data. So what the stratify means, this can solve this problem of inconsistency, because this problem can affect your model. Your model is learning that in the real world you have 90% of yes and 10% of no, but if you test that model, then the model will get like 80% yes and 20% no. Then this is not a good practice. So you have to confirm that the data is, means you can tell that the ratio of the classes or the ratio of the categories will be same, will be mostly same. This is the main thing here. Okay, so how to apply stratify? Just do one thing. When you are applying the train test split TTS function, and x and y and test size is equal to 0.2 or anything, and random split is equal to 42, and you will be giving a extra parameter that is stratify, that is you will giving y means yes, so you are applying stratify is equal to true. So the splitting will be stratified. So just test it, this with code. Suppose this is the previous notebook I was using in the previous class. So okay, at first test without stratify. This time I will be taking the target column as this charging type, because this contains fast and slow, two categories. Let's check one time. Df of charging type dot value counts. Yes, you can get fast and slow. So at first try using without stratify. Okay, then first define x and y. X is df dot what I can tell, df dot drop. Okay, df dot drop columns is equal to and y is equal to df of charging type. Okay, now x train, x test, y train, y test. Okay, train test split x y test size and 2, and random state is equal to 42 and stratify. Okay, this is I am testing without stratify. So the y train, first check for y train, because y train is the target column, so I have to check the category ratio. So suppose data 1 is equal to y train dot value counts. Okay, this will give me, and I can also plot the plot this curve. Yes, this curve. So how to plot? Import matplotlib.py plot as plt dot okay, at first print data 1, plt dot matplot bar data 1. So let's take it only data. Data dot index, data dot values. Okay, So this is giving fast and slow. These are two categories, and you can also check the fast is 670 and slow is 134. So suppose 670 by 134, that is giving 5. 670 by 134, that is giving 5. So for not stratify, and this is stratify, what I am getting 5 for the train. For the train. Okay, so check for the test also. This is for the train, for y test, and here I have to change. Yes, this is done. For y test, 165 and 37, 165 by 37, 4.45. 4.45. Okay, now this is the case of the not stratify. So if I do it using stratify, use stratify, copy this, use stratify is equal to true, is equal to y. 667 137, 667 137, 4.86. For train, 4.86 for train. Okay, and for test, one 168 by 34, 4.94, 4.94. So you can see the gap between these and between these. This gap is like 4.45 to 5, like 0.55. This difference is 0.55, and this state difference is 0.08. Okay, you can see that this difference is much lower than this. So this is important. This dataset is not that imbalanced. This dataset is not that imbalanced, but in future you will get this get some dataset which will be like this is 99% and this is 1%. So this will matter more in that case. So you have to use the stratify to get the balanced distribution. Okay, goodbye.